Somewhere in Japan, a train leaves a station, accelerates faster than most cars on the highway, reaches speeds that once sounded impossible, and carries hundreds of passengers without anyone feeling a single vibration. A glass of water can sit on a table inside, and it barely moves. Outside, the landscape is flying past the window at more than 300 kilometers per hour. Inside, someone is drinking coffee, someone else is working on a laptop, a child is sleeping, and the train arrives almost exactly when the schedule said it would. Not close, not within a few minutes, within seconds. This is not a futuristic concept built for a technology exhibition. This is not a prototype hidden inside a research facility. This is a train system millions of regular people use every single year. And here is the part that makes engineers around the world pay attention. Japan built the first version of this technology more than 60 years ago, before smartphones, before the internet, before humans even landed on the moon. In 1964, while most countries were still improving traditional railways, Japan introduced something completely different: the Shinkansen, the bullet train. A machine that did not just make trains faster, it changed what people believed a train could be. Because before the Shinkansen, railways around the world were starting to look outdated. Cars were becoming popular. Airplanes were becoming faster. Many experts believed the golden age of trains was ending. They thought the future belonged to highways and airports. Japan looked at the same problem and reached a completely different conclusion. They did not ask, how do we make old trains a little better? They asked, what if we rebuild the entire idea of a train from zero? And that single question created one of the most advanced transportation systems ever built. A system so precise that the average delay is measured in seconds. A system that has carried billions of passengers. A system that became so reliable that people stopped thinking about how extraordinary it actually is. Because when something works perfectly every single day, humans stop noticing the miracle. But the engineering behind it is almost unbelievable. And to understand why Japan created something the rest of the world struggled to match, you have to understand what Japan looked like before the bullet train existed. Because this story does not begin with speed. It begins with a problem. A country with mountains everywhere, limited space, growing cities, and millions of people who needed to move faster than ever before. Japan is not built like many other countries. It does not have endless flat land. Around 70% of the country is covered by mountains. Cities are squeezed into narrow areas between mountains and the ocean. Tokyo was growing. Osaka was growing. Factories were expanding. The economy was accelerating. But the transportation system could not keep up. The old railway between Tokyo and Osaka was reaching its absolute limit. More trains could not simply be added. The tracks were already full. The country needed something radical, something that sounded almost impossible. A train faster than anything people were used to. A train that could compete with airplanes. A train that could move an entire nation. The timing made the challenge even bigger. Japan wanted to reveal this new technology before the 1964 Tokyo Olympics. The entire world would be watching. Failure was not an option, and the engineers were not just building a faster train. They were fighting physics itself, because the faster a train moves, the more problems appear. The wheels become unstable. The air creates resistance. Noise increases. Safety becomes harder. Small vibrations become dangerous. At normal speeds, a tiny engineering mistake is uncomfortable. At bullet train speeds, a tiny mistake can become a disaster. So Japanese engineers started solving problems differently. They built completely new tracks, no crossings, no cars, no interruptions. The Shinkansen would have its own dedicated world, a railway designed only for speed. Then they changed the shape of the train. Instead of fighting the air, they studied it. The front of the train became long and aerodynamic. Not because it looked futuristic, because every curve had a purpose, every centimeter mattered. This became one of the most important ideas in Japanese engineering. Do not add more power until you remove every possible weakness, perfect the small details, then perfect them again and again. That philosophy is why the Shinkansen became something much bigger than a fast train. It became a symbol of how Japan builds. But speed alone is not the most shocking part, because other countries eventually built fast trains. France built the TGV. China created the largest high-speed network on Earth. Europe continued improving rail technology. But Japan had something different, something much harder to copy, a culture of precision, a system where being 1 minute late is considered unusual, and the next breakthrough would push that idea further than anyone expected, because Japanese engineers were about to ask another impossible question. What if a train did not need to touch the tracks at all? The train that does not touch the tracks. For most of human history, every train had the same basic limitation: contact. Metal wheels touching metal rails. It sounds simple, it sounds reliable, and it is. But when engineers try to push trains beyond normal speeds, that contact becomes the enemy. At higher and higher speeds, every tiny vibration matters. Every imperfection in the rail matters. Every movement between the wheel and the track creates resistance. Japanese engineers looked at this problem and asked a question that sounded impossible. What if we removed the wheels completely? What if the fastest train in the world did not roll? What if it floated? That idea became one of the most ambitious transportation projects ever attempted, the Japanese Maglev, a train that uses magnetic forces powerful enough to lift the entire vehicle above the track. No traditional wheels carrying the train, no engine pulling it from the front, no normal railway system underneath. The train literally levitates. And once you remove physical contact, something incredible happens. A limitation that existed for almost 200 years disappears. The only major obstacle left is air itself. In 2015, Japan tested the L0 series Maglev, and the number it reached shocked the transportation world: 603 kilometers per hour, 375 miles per hour. To understand how fast that actually is, imagine leaving New York City. In 1 hour, you could almost reach the distance of Washington, D.C. and come back. On the ground, without an airport, without waiting for boarding, without taking off, without landing, just a train. But the speed is not the most impressive part, because anyone can build something fast once. A rocket is fast. A race car is fast. The real question is, can you make extreme speed normal? Can you make it safe enough that regular people trust it every morning? That is where Japan's approach becomes different, because Japanese engineers were never obsessed with building the fastest train. They were obsessed with building the fastest train that feels ordinary, a machine doing something extraordinary while the passenger barely notices. Inside the Maglev, there is no feeling of a machine fighting against physics. No shaking, no aggressive engine noise, no feeling that you are moving faster than a commercial airplane during takeoff. Just silence, stability, control. And that philosophy goes all the way back to the original Shinkansen, because when Japan introduced the bullet train, the world focused on speed, but Japan focused on something else: safety. Since the first Shinkansen began operation in 1964, the system has carried billions of passengers, and one statistic became legendary: 0 passenger deaths from train accidents. Think about that. Billions of people, thousands of trains, decades of operation, a machine moving faster than almost anything else on the ground. And the system was engineered so carefully that safety became part of its identity. That did not happen by accident. Japan built technology around one simple idea: prevent the problem before the problem happens. The trains constantly monitor themselves. Sensors analyze conditions. Systems detect earthquakes. Automatic controls can react faster than humans, because at 300 kilometers per hour, a human reaction is already too slow. The machine needs to think before the passenger even knows something happened. And nowhere is this more important than earthquakes. Japan sits in one of the most earthquake-active regions on Earth. Building a high-speed train there sounds almost impossible. Other countries worry about normal railway problems. Japan had to solve: how do you safely run run a train faster than 300 kilometers per hour in a country where the ground itself can move? The answer was a system that detects earthquakes before the strongest shaking arrives. The moment sensors detect dangerous activity, emergency systems can slow or stop trains automatically. Seconds matter, and Japan designed around those seconds. This is the hidden reason the Shinkansen became so respected. Not because it was fast, because it made something incredibly difficult look easy. The same philosophy appears everywhere in Japanese engineering, a vending machine that works perfectly for years, a factory robot repeating the same movement millions of times, a train arriving exactly when expected. The goal is not only invention, the goal is refinement. Taking something that already exists and improving it until the rest of the world wonders how such a small difference became such a massive advantage. But even after building some of the fastest and safest trains ever created, Japan faced another challenge. Because technology alone does not create a transportation miracle, a train is only as good as the system around it. And this is where the difference between Japan and many other countries becomes even more obvious. Because the most impressive part of Japanese trains is not the machine, it is the invisible world built behind it, the people, the process, the discipline. The reason a delay of just 1 minute can become national news. And that story begins with something that looks almost impossible from the outside. How does a country move millions of people every single day without everything falling apart? The invisible system behind Japan's impossible trains. When people around the world look at the Shinkansen, they usually notice the obvious things first. The futuristic shape, the incredible speed, the technology that allows hundreds of passengers to move across the country faster than anyone imagined decades ago. But the real reason Japan's train system became legendary is not only the machine itself, it is everything built around the machine. Because Japanese engineers understood something that many countries discovered much later. A train can be extremely advanced, incredibly fast, and beautifully designed. But if the system supporting it is not equally advanced, the entire experience breaks down. A 5-minute delay can destroy connections. A slow boarding process can waste the speed gained on the tracks. Poor maintenance can turn an engineering masterpiece into an unreliable machine. So Japan did not only design a faster train, they designed a complete ecosystem where thousands of tiny details work together every single day. Every morning, millions of people move through Japan's railway network. Stations fill with passengers. Platforms become crowded. Thousands of trains enter and leave cities. And somehow, the system continues moving with a level of precision that almost feels impossible from the outside. But that precision did not happen because of one invention. It came from decades of improving small things most people never even think about. The exact position where doors stop on the platform, the movement of passengers through stations, the way signs are positioned, the way trains are inspected, the way workers communicate. Every small piece has been studied, tested, and improved. Because in Japan, efficiency is not only about making the train faster, it is about removing everything that slows the journey down. One of the most famous examples happens after the train arrives at the final station. For most people, cleaning a train is one of the least interesting parts of transportation. It is something that happens in the background, something passengers rarely think about. But Japan treated even this simple process like an engineering challenge. The cleaning teams responsible for preparing the Shinkansen have only a few minutes before the next passengers arrive. In that time, they inspect the cars, clean the interior, rotate seats, check details, and prepare the entire train for another journey. The process became famous because it represents something much bigger than cleaning. It represents a philosophy, a belief that every second matters, a belief that every detail contributes to the final result. Because a train capable of moving faster than 300 kilometers per hour loses its advantage if it wastes unnecessary time standing still. This way of thinking connects directly to one of Japan's most famous ideas, Kaizen, continuous improvement, the idea that something does not need to be broken before you improve it. Even a system that already works can become better. A small improvement today, another improvement tomorrow, repeated thousands of times until the final result looks impossible. That philosophy shaped every generation of the Shinkansen. Each new model became quieter, more efficient, more comfortable, more aerodynamic. Not because the previous version failed, because perfection was always treated as something you move toward, not something you reach. And one of the greatest examples of this mindset came from a problem nobody expected: noise. As Japanese trains became faster, engineers discovered that speed created a new challenge. When a train entered a tunnel at extremely high speed, it compressed the air in front of it. That pressure traveled through the tunnel and created a loud sound when the train exited. Engineers had solved the problem of speed, but now they needed to solve the problem created by speed. A simple answer would have been to slow the trains down, but Japanese engineers searched for another solution, and surprisingly, they found it in nature: a bird, the kingfisher. This bird can dive from the air into water at high speed while creating almost no splash. An engineer noticed that this was actually a similar problem. How do you move from one environment into another without creating a powerful pressure change? The shape of the kingfisher's beak became an inspiration: long, smooth, efficient. The front of the train was redesigned. The result was not only less noise, the train also became more energy efficient. A bird helped improve one of the most advanced transportation machines ever created, and that single story explains why Japanese engineering became so respected. The goal was never just to add more power. The goal was understanding the problem deeply enough that the solution almost feels obvious afterwards. While others often asked how to make machines stronger, Japan repeatedly asked how to remove the weaknesses that were already there. That difference created a railway system that became famous around the world. But the story is not finished, because after building the bullet train, after developing magnetic trains that can float above the track, after creating one of the safest transportation systems ever built, Japan started preparing for the next question. If a train can compete with cars, if a train can challenge airplanes, what happens when distance itself becomes the next problem to solve? That is the future Japanese engineers are trying to build now, and it could change how humans think about travel forever. The future of transportation Japan is building next. For more than half a century, the Shinkansen changed how millions of people understood distance. A journey that once required a long day of travel became something people could do in a few hours. Cities that once felt separated started feeling connected. Business changed. Tourism changed. The way people planned their lives changed. Because transportation does something much bigger than simply move people from one place to another. It changes what people believe is possible. Before the bullet train, a person living hundreds of kilometers away from a city had to think carefully about every journey. Travel required planning, time, energy. But when transportation becomes faster, something interesting happens. The map itself starts to feel smaller. A place that once felt far away becomes part of your normal life. And this is exactly the idea behind Japan's next generation of trains, the Chuo Shinkansen. The magnetic levitation line designed to connect Tokyo and Osaka in a completely new way. For decades, Tokyo and Osaka have been two of Japan's most important economic centers. Millions of people, thousands of companies, two massive engines of the Japanese economy. The original Shinkansen already connected them faster than anyone thought possible in the 1960s. But Japanese engineers looked at their own achievement and asked the same question they always ask: can it be better? Not because the old system failed, because improvement never stops. The answer was a train that does not behave like a traditional train at all. The Maglev, a machine that lifts itself above the guideway using magnetic forces. A machine designed to travel at speeds that move closer to aviation than normal rail. A machine created around one goal: make two distant cities feel like one connected region. Because when travel time drops dramatically, something bigger happens. The train does not only change transportation, it changes society. People can live differently. Businesses can operate differently. Opportunities can spread differently. This is the hidden power behind every major transportation revolution. The steam train connected countries. The automobile expanded cities. The airplane connected continents. And Japan believes the next step is making high-speed ground travel so convenient that people rethink the need for short flights. Because airports have a problem trains do not. A flight may only take 1 hour, but the journey is not 1 hour. You travel to the airport, you check in, you wait, you board, you land, you leave the airport. The actual movement through the sky is only part of the experience. Japan's idea is different. Walk into the center of one city, enter a train, step out in the center of another city. simple, fast, predictable. That is why the Shinkansen was never really competing with other trains. It was competing with the entire idea of travel. And this is why so many countries tried to create their own versions. France built the TGV. China created the largest high-speed rail network ever constructed. Countries around the world invested billions into faster trains. But Japan's original achievement remains unique because it was not only about reaching a number on a speed test. It was about creating trust. A technology becomes truly powerful when people stop thinking about the technology. Nobody wakes up in Japan amazed that their train arrives safely. Nobody celebrates that a machine traveling faster than a race car reaches its destination exactly as planned, because it became normal. And that may actually be the greatest engineering achievement of all, making the extraordinary feel ordinary. That same idea appears throughout Japanese innovation. The best technology is not always the loudest. It is not always the biggest. It is not always the one that looks the most futuristic. Sometimes the greatest technology is the one that disappears into everyday life because it works so well. The automatic doors open, the train arrives, the passenger sits down, the journey happens, and nobody thinks about the millions of engineering decisions that made that moment possible. More than 60 years ago, Japan introduced a train that many believed was unnecessary. Some people thought railways belonged to the past. Some believed airplanes and highways would replace them. But Japan saw something different. They saw that the future was not about abandoning trains. It was about reinventing them. The first Shinkansen proved trains could be fast. The next generations proved they could be reliable. The Maglev proved they could become something completely different. A vehicle that floats, a machine that challenges the boundary between railway and aircraft, a technology that started with one simple question: what if we build the future instead of waiting for it? And that is the real story of Japan's trains. Not steel, not magnets, not speed records. The real story is a country that looked at an old idea and refused to accept that it had reached its limit. Because sometimes the biggest breakthroughs do not come from creating something completely new. Sometimes they come from looking at something everyone already understands and asking one more question: how much further can we take it? If you enjoyed this story, subscribe for more incredible engineering breakthroughs from around the world, because the future is not always waiting somewhere far ahead. Sometimes it is already moving, quietly, perfectly, at 300 kilometers per hour, right in front of us.